Okay, I'm going to be documenting here how I make a bed frame from welded steel. This will be really my second project I've done with my new welder. The first one was this rack I made to hold the steel for projects like the bed frame. And yeah, I'll be walking through it with you because this will be my first time as well, so you'll see my mistakes as well as my successes. First thing to do is to lay out a plan, of course. I'm going to do it for a queen size bed, which is basically 60 inches by 80 inches. You need to establish what height you want and so forth, and what kind of construction you want. I chose to make it into 5 pieces that are bolted together, so it could be disassembled and reassembled and gotten through the doors and manhandled and so forth. Hand sketches seem to work about the best for me as far as what's necessary, but I did play with the SketchUp application to come up with a basic layout, make sure it was feasible to do and so forth, but that's not a requirement, of course. Next thing I did was do a material takeoff. Basically I'm using a hot rolled steel, square steel tubing, angle iron, and bar stock. I specified all the lengths in advance, and the material supplier cut all the lengths for me in advance. I then pre-cut as many of the component parts to be welded as possible. This portable bandsaw mounted on a really handy dandy table works great for that purpose. These 3/16 steel gussets, I was cutting at about 4 inches a minute, so it didn't really take any time at all to cut these to size and shape. I then laid out and pre-drilled all these attachment flanges from bar stock. I used a template, like I think it was this number 1, that I laid out carefully, drilled carefully, and then used it to drill all the other 3 brackets. And then I used the same template to pre-drill the square tubing for the posts. That way everything fits up really well. 1/2 inch diameter holes for 1/2 inch bolts. It helped to have a nice drill press with a cross feed table like this to do it on, but not essential. Now comes the tedious but critical step of jigging these joints together in such a way that we know they're square and aligned and spaced properly. The whole purpose of this exercise is to get this joint here jigged up properly with the right gap and the right distance to the other one at the other end, and all squared away so that when we tack this joint in place, it'll stay there. And like I say, it's tedious, but with enough clamps and patience and a little jury rigging, it can be done. So the whole challenge was to get both posts vertical using a level in all directions, parallel to one another, and spaced properly. And by the way, it helps to start with a relatively flat level floor, but that can be compensated for if you're careful. The cross brace really helps hold everything together. As you can see with enough clamps, this is good and sturdy. It's not moving. So when I weld it, these joints won't pull things out of square when distortion due to heating and cooling occurs. The next step is to grind, polish the surfaces that are going to be welded. This is important because it prevents contamination of the welding once you've started. Very important to do soon before welding, preferably the same day as you do the welding. At least that's what I've been taught in my minimal training as a welder. So I guess lesson number 1 might be to plan the work so that I'm doing all the grinding and jigging and welding on the same day. That way I could have ground all the surfaces to be welded with these brackets up on the bench instead of in place here where it's pretty awkward and cumbersome to get to. but I'm managing to do it here in place after it's all been jigged up without disturbing anything. I also ground a bevel on the edges where I needed a V-groove for the weld rather than a fillet weld. By the way, if you're a welder, you may be interested. I'm going to be using this Miller Multimatic 215 weld machine. It's pretty new. I've got it on the 240 volt setting, although it could run on 110. I'll be using pretty much the standard settings. Yeah, it's DC electrode positive. I'll use the 25% CO2 gas. I generally set it around 20 cubic feet an hour. And yeah, the .030 solid wire size. Yeah, so it's pretty much standard settings for welding carbon steel. Practice welding a little bit. Okay, we're tacking the fixture in place. Lesson number 2, don't get so excited that you weld the wrong joint. I tack welded this bracket to the post when I really just needed to tack those angle irons to each other, so I'll have to grind that one off. Duh. Okay, I just spent quite a bit of time jigging up and tacking these joints in place, but I think it will definitely pay off in the future because it looks like the fit up is real good and it'll make the whole frame square later. One of the lessons I learned in doing this work is, gee, if I had designed more carefully and slowly, I would have realized that these two pieces here could have been made from one angle steel, but I designed it in stages and came up with this gusset later and didn't back up and say, could have made this out of one piece instead of two, but hey, gives me more chance to practice my welding. Okay, so the welding on these brackets is done on this half anyway. Not beautiful, but functional. All that jigging and careful alignment, I think, paid off because the posts are definitely square with each other, even when it's only loosely bolted together. And here I've finished the second side rail bracket system. A couple of observations, not really lessons learned, but just in general. Like a lot of things, the planning and setup time is the majority of the work. The actual execution of the welding goes pretty fast. And the other thing is, like a lot of things, the second one goes a lot faster than the first one. Okay, the next step is to square up and rig the entire frame and to prep these cross rails for welding on the edges. I'm beveling the corners and I'll be grinding the surfaces to clean them up before welding on these and the posts. Cover your eyes. Now disassemble it again and finish off all these welds in an optimal welding position, which is generally down. More grinding to prep for welding the foot plates to the bottom of the posts. Okay, I put this step off till as late as possible, but now that the foot pads are welded on, I need to be able to hold the nuts inside the square tube when we bolt the corners together. So I'm drilling out 1 inch diameter holes opposite the half-inch holes for the rails. And this does help to have a nice drill press and set up. And other than that, most of the tools I've been using are pretty basic. So one of the things I've really learned is to use these caster wheels on the welding table and a good bench press with a cross feed system really helps position the parts for drilling with a minimum amount of manhandling and a maximum accuracy. Alexa, turn off the upstairs switch. Seems like there's always more involved in the job than it first appears. Now I'm having to move the drill press from a lower position to an upper one, and it's heavier picking it up than it was dropping it down. Thankfully, that worked like a champ. We're getting down to some of the final details now, like welding this center post to the cross member and drilling holes for it in the rails. The last significant bit of metal work, and I'm finishing off here, is to drill and tap these holes around the back side of the headboard for future attachment of some kind of decorative thing in the middle. I'll cut this strap here and drill it to splice some kind of headboard that I can change from time to time, change out just by unscrewing it from the back of the headboard and putting in a new one. So it really helps to have a vertical mill in my dad's shop that we used to machine out these post feet and caps from wood, from 2 inch thick white oak. Okay, so the next step is to do a good job scrubbing with a strong degreaser and then rinse it with really hot water, which is obviously a big job, but it's going good. After it's clean and dry, then finish it off with about 4 coats of Rust-Oleum clear. Okay, so here's the final product installed in place. It worked out great. We definitely learned some lessons on the way, but you come in and look, these corners worked out well. The wood pieces I cut from white oak fit nicely, and the joints on the sides all polished up well with a little clean up, and then painting with a clear coat of several clear coats of enamel. And yeah, the only thing we did in addition to the original design was, after we put it on here, thankfully the mattress fits beautifully, but I decided to put in additional cross braces at the foot and the head of the box spring, because that's got a little bit of flex in the box spring that I didn't expect. Other than that, yeah, it's very sturdy and comfortable. Okay, so here's the final product with the headboard installed. Turned out well, I think. My wife and I both like it, and I'll show you some details here. Also finished off the feet of the posts by caulking between the metal base plates and these wood feet and putting felt underneath them for each of the 4 corners. And I'm really happy with how some of the special features of the design have turned out. So in summary, the project's been a lot of fun, a real learning experience. I have had quite a few lessons learned, still learning. I had a minimal amount of problems, no rework to speak of, except for grinding off that one tack weld that didn't go in the right place. And I had no injuries, thankfully. Wore lots of PPE along the way. I'm still learning to tack weld, if you look closely at these. But, and yeah, the schedule went long, as often is the case, and the cost of the materials was definitely higher than I originally forecast, mainly by adding the headboard. As efficient as I got at it, I'm thinking, for me anyway, this is probably not the way I'm going to make a living. This is more a labor of love. That's it.